On the morning of October 13th, the crew members woke up at their hotel in Luxembourg to prepare for the trip, designated as Flight 1601 outbound and Flight 1602 on the return. The flight crew had arrived in other aircraft the previous day, while the ground engineer and the loadmaster were already on duty, having arrived in Luxembourg that same day from Johannesburg, South Africa, on the same Boeing 747. When Flight 1601 departed Luxembourg at 15:56 European time, it was nearly 6 hours behind schedule. But at MK Airlines, crews were simply expected to extend their duty date to accommodate the delay. Already scheduled for a 24-hour, 30-minute shift, the pilots would now have to stay awake considerably longer to complete the return flight to Luxembourg, first passing through Bradley, Halifax and Zaragoza. 8.5 hours later, at 19:22 local time after the time change, Flight 1601 landed at Bradley Airport in Connecticut, where ramp personnel unloaded its original cargo and loaded a shipment of lawn tractors, several pallets of consumer goods, and a 13-ton steel roll. October 14th, 2004. Bradley Airport, Connecticut, USA. Just past midnight, MK Airlines Flight 1602 began to taxi to the runway for takeoff. This leg was to last about an hour, heading to Halifax, Nova Scotia, Canada. In 1990, Zimbabwean Michael C. Kruger founded a cargo airline called MK Air Cargodor, which began operations that year with a single Douglas DC-8. Due to Zimbabwe's unstable political climate and less than optimal location, the airline was registered in Ghana, a West African nation, while its corporate headquarters was initially in Nigeria and later near Gatwick Airport in the United Kingdom. The airline, renamed MK Airlines Limited in 1993, began transporting cargo to and from Africa and later around the world, using a growing fleet of DC-8s and eventually Boeing 747s. By 2004, it had 12 aircraft, including 6 747s. While the 747 was at Bradley, 2 of the crew members were replaced, with Captain Thornycroft and Flight Engineer Launder taking over from the original crew members, Lamb and Hooper. During takeoff, the pilots used what is known as reduced thrust, an engine power setting below maximum thrust, suitable when the plane's load is below a specific weight, thus reducing engine wear. Since the aircraft wasn't carrying a large amount of fuel, the 747 was relatively light, so maximum thrust wasn't required to reach takeoff speeds. Just a few minutes after 1 a.m., Flight 1602 landed at Halifax Airport, where it proceeded to the cargo area to pick up several thousand kilograms of frozen lobsters. At the same time, a large amount of fuel was loaded for the transatlantic flight to Zaragoza, Spain. At the controls of this 24-year-old 747-200 was Captain Michael Thornycroft, who had been with MK Airlines since its creation in 1990. He had 23,200 flight hours, including 4,000 hours on the Boeing 747. Beside him was First Officer Gary Keogh, with 8,537 flight hours. The flight engineer was Peter Launder, who had 2,000 flight hours. Also on board were a relief captain and a relief flight engineer. The relief captain was David Lamb, and the relief flight engineer was Stephen Hooper, who had 1,600 and 1,990 flight hours, respectively. The ground engineer was Mario Jan, who held dual South African and German citizenship, and the loadmaster was Chris Streedom. 6 of the 7 crew members were from Zimbabwe. The 7th, Captain Thornycroft, was from South Africa. After the frozen lobsters and fuel were loaded, the 747 had a total weight of 353,000 kilograms, 113,000 kilograms more than when it departed Bradley. At this point, someone needed to use the load sheet information to calculate the aircraft's takeoff performance figures, including proper engine power settings and the so-called V-speeds. V1, the highest speed at which the takeoff can be aborted. VR, the speed at which the pilot rotates to lift off, and V2, the safe climb speed. Traditionally, these figures were calculated manually by referencing page after page of speed tables in the flight manual. However, just a few months earlier, this task had been taken over almost entirely by computer programs. All Boeing aircraft were equipped with a laptop loaded with a program called BLT, Boeing Laptop Tool, an application capable of calculating all takeoff parameters through manual input of various data, such as weight, flaps, runway length, and engine type. During this stop in Halifax, the software should have been used roughly as follows. After receiving the load sheet from the loadmaster, First Officer Keogh would have gone to the laptop and opened the BLT to the performance section. There, he would have found 2 versions of this page, one for reduced thrust takeoff and another for maximum thrust takeoff. Takeoff could be calculated in both, but if the total weight was greater than required for reduced thrust takeoff, the program would show an error and ask the user to input the data in the maximum thrust section. Both the co-pilot and the loadmaster were well aware of which tab to use based on the previously calculated weight. However, they were unaware of the misunderstanding that could arise from using the BLT without paying full attention. And this, on a day like today with a 24-hour shift and no sleep, was something that could happen. Co-pilot Keogh entered the data, and once he finished, he manually filled out the performance sheet that MK Airlines provided to the crew. He then handed it to the captain, who was initially supposed to verify the data before configuring the aircraft for takeoff. But Captain Thornycroft wasn't a big fan of laptops. The captain and engineer configured the aircraft, and a few minutes later, they were moving toward the assigned runway. Finally, at 2:53 a.m., the MK 747 began accelerating down the runway. The co-pilot called out the approach to V1, then VR just seconds later as they had been rolling for 1,600 meters. The plane had just reached the 130 knots indicated on the sheet generated with the BLT as the rotation speed. There were approximately 1,000 meters of runway remaining. The captain gently pulled back on the controls to lift off. The nose gear lifted quickly, but something wasn't right. The main landing gear wouldn't lift off. Moments later, the captain pulled harder, but the massive jumbo jet loaded with 350 tons didn't climb. With only 240 meters of runway left, the captain pulled with all his might, causing the tail of the plane to strike the runway forcefully, scraping and generating a shower of sparks. Less than 2 seconds later, he moved the throttle levers to toga position. But the plane didn't take off as the engines took several seconds to respond. As the 747 raced off the end of the paved surface, the main landing gear barely began to lift off. But the tail continued scraping against the pavement and then the grass. The pilots were doing everything they could, but it wasn't enough. The tail finally lifted off the ground, but the plane was heading straight for an embankment that supported the instrument landing antennas, and beyond that, a forest dense with trees. Moments later, with a tremendous crash, the tail struck the embankment, tearing off the entire empennage and destroying the antennas. The rest of the plane remained airborne for a moment, paralyzed with no possibility of recovery, then pitched down and crashed nose first into the forest's first trees, where it struck the ground, sending large sections of the 747 scattering across the forest in a huge ball of fire. Even though firefighters arrived on the scene within 5 minutes, they were met with an apocalyptic inferno, leaving little hope that anyone on board had survived. The remains of the 747 and its cargo were scattered over several hundred meters from the embankment, across a forest and to the edge of a quarry, and almost everything was ablaze. When the rescue teams finally reached the crushed and charred remains of the cockpit, it was clear that the 7 crew members had died instantly when the 747 crashed nose first into the ground. What had happened? Was the plane improperly configured for takeoff? Within hours of the accident, investigators from the Canadian Transportation Safety Board (TSB) arrived on site. Their first priority was to find the black boxes from the 747, which were mounted in the central section above the wings. Unfortunately, that was the area most damaged by the fire, and the integrity of the data contained in the recorders wasn't entirely clear. When the boxes were pulled from the ashes, it was immediately apparent that the cockpit voice recorder had been destroyed. In fact, the tape inside the recorder had melted completely from prolonged exposure to the fire. As a result, we will never know what the pilot said before the accident. The investigators' work would have been even more challenging if the flight data recorder hadn't miraculously survived the inferno. This revealed that the engines weren't producing enough thrust, and that the pilot attempted to climb at an airspeed that was too low, causing a tail strike and runway excursion that ended in the fatal collision with the embankment. This necessarily raised the question of whether the embankment should have been there, and whether the pilots might have been saved without that nearby obstacle. The embankment was built in 2003, the previous year, to raise the height of the airport's instrument landing system equipment, bringing it into compliance with international standards related to range and coverage. Positioned more than 1,000 feet from the runway end, about 305 meters, it lay outside the required obstacle-free zone, intended to protect planes experiencing problems on landing. Moreover, the sloping terrain in that area meant that the concrete platform on top of the embankment was actually level with the runway, so it wasn't considered an obstacle for arriving or departing aircraft. Therefore, the embankment met all regulatory requirements. The more pressing question for investigators was why the plane didn't have enough thrust for takeoff. No mechanical issues were found, and the engines responded quickly when the pilot ordered acceleration just before impact, demonstrating they were in good condition and capable of producing enough power. Finally, thanks to data revealed by the surviving black box, they discovered that both the V-speeds and the engine's EPR values were miscalculated. The engine pressure ratio, or EPR, is used to indicate power output on a jet engine. In this case, the pilot set an EPR of 1.3, insufficient to lift off before running out of runway. A maximum setting of 1.6 would have been required for this 747 takeoff. After many months of studying the company's procedures and the Boeing Laptop Tool, or BLT, investigators arrived at a single likely scenario. Whoever used the BLT to calculate the takeoff parameters did something that led to using the same data as the previous takeoff at Bradley, where they had taken off with 130 tons less weight. A closer study of the application demonstrated there was a way to confuse the user, and this is possibly what happened. Co-pilot Keo probably entered the load data correctly to obtain the proper takeoff configuration using the maximum power tab. But before manually copying these data onto the performance sheet provided by MK Airlines, he likely inadvertently clicked on the Reduced Thrust tab. Investigators found that when switching to Reduced Thrust, the last data loaded in this section automatically appeared when it should have been empty to avoid confusion. Afterward, the co-pilot copied this data onto the sheet without realizing they were from the previous takeoff, likely due to accumulated fatigue and a desire to rest before heading to Zaragoza. Boeing provided the option in its software to print the generated performance sheet directly. Perhaps if he had used this option, the error wouldn't have occurred, but the limited use of this software among airlines meant that the procedures weren't yet clearly defined. Clearly, the captain didn't double-check the datasheet. It's mandatory that the captain perform the same process as the co-pilot on the laptop to prevent such catastrophic errors. But the captain, as previously mentioned, wasn't a fan of laptops and neglected to perform his verification duties. According to MK Airlines' company policy, the maximum duty time for a 747 crew operating 4 legs was 24 hours, with a maximum of 18 hours spent in the air. This gave MK Airlines literally one of the least restrictive flight duty schedules of any airline known to Canadian authorities. An average airline pilot in the US has a duty time limit of barely half that. After reviewing the crew schedules for MK Airlines' Boeing 747 over several months, the TSB determined that 71% of all duty periods were scheduled above the 24-hour limit, including the accident flight. It goes without saying that these long duty periods severely impacted the pilots. The airline had developed an official policy allowing a pilot to return to the crew compartment to sleep during the flight, something not permitted under international rules. But this wasn't enough to address the severe fatigue that developed over these long shifts. In fact, even with naps taken during the flight, this sporadic and limited sleep during such long periods left flight crews seriously affected, with reduced alertness, slower reaction times, and impaired judgment. Relief Captain David Lamb had complained about this in a trip report just hours before he died in the crash of Flight 1602. Despite all their damning findings, the TSB issued only one recommendation: that passenger aircraft be equipped with a system that can alert the crew if performance is insufficient for takeoff,